Hello, Professor. This is our demo for employee attrition MLOps project. This is developed as a part of MSc Data Science and Computer Science at ESILV. So, in this demo, I'll be talking about our complete MLOps pipeline, including the machine learning training workflow, experiment tracking with MLflow, API-based model serving using fast API, and containerized deployment with Docker. So this project was developed across four checkpoints and demonstrate a production style machine learning system following modern MLOps practices. And this is our GitHub repository, and this is the main branch. And these are the active branches which individuals are working and should be merging to into the main branch. So let me first show the overall structure of the repository. So I'll be showing here with Visual Studio Code, the same which I have opened in the GitHub repository. So all the source code lives inside the SRC directory, where you can see here, which is divided into two main modules, the AP layer and the model training layer. So the script folder, which contains the training entry point used to run the full pipeline. And there's one test directory. If you can see a test directory here, which contains unit test implemented with PyTest and our coverage is above 70%. The training machine learning model is stored in model.job library, and the mlflow.db you can see here. We store the experiment tracking metadata for all mlflow runs, and the Docker file defines how the entire application is packaged into a container, and our dependency management is handled using pyproject.tom and uvlog. Finally, there is one pre-commit config YAM. Pre-commit hooks are configured using here to enforce the code quality, like some when using like across the system, across the team. So next, I want to show pyproject.com. So this is a dependency management. The project uses uh, UV, a modern Python package manager for dependency management and environment reproducibility. So we explicitly pin the Python version to 3.11 to ensure every developer and deployment environment run on the same interpreter. And our production dependencies, you can see here, include fast API for the API service, MLflow for experiment tracking, split learn for the machine learning pipeline, pandas and MP for data handling, and UVCon as the ASGI web server. And the dev dependency you can see here, the development tools as PyTest coverage, and pre-commit are included separately to support testing and code quality. And the UV log, uh, which logs every dependency to the exact version, like if someone else is cloning the repository in future, or some other one of other member cloning the repository, we should they can recreate the exact same environment by logging the dependency versions. And code quality in this pre-commit config YAML, this enforce code quality we configure here, which automatically runs before every commit. So the first tool you can see black, which automatically formats Python code to enter Python code, so the entire team can follow the same style. And the ISOT organizes import statement into logical groups such as standard library, third-party libraries, and local modules. And lastly, the Flake 8, which performs static analysis and detects issues such as unused variables or style violations. So now we have in SRC, attrition, models, we have train.py. So, so let's look into the core machine learning training pipeline. The targeted variables are encoded as a binary classification level where one, you can see one represents employee attrition and zero represents employee who stay. We separate the futures into numerical and categorical groups because they require different pre-processing techniques. You can see numerical and categorical. And we have a column transformer that applies different pre-processing transformation in parallel. Numerical features are standardized using standard scalar, while categorical features are encoded using one-hot encoder. And the data set is split into 80 percentage. You can see here uh, model, job, library. Yeah. So the data sets is split into 80 percentage training data and 20% are testing data to evaluate model performance. So you can see here. And uh, after training, the entire pipeline is serialized into a model.joblib file, which contains both pre-processing and trained model. So next I'll be showing the train pipeline. I'm closing this here. The train pipeline I want to show. In this file, we integrate ML flow to track experiments and ensure reproducibility. So each training runs logs parameter, evaluation metrics, and model artifacts. So when the training script is executed, the ML flow automatically records the experiment in the tracking server. So using ML flow, we can compare multiple runs, track performance metrics, and store model artifacts for deployment. So next I will be showing uh, the Docker file. So when we are seeing the Docker file, okay. So the Docker containerization. To ensure probability, portability, and reproducibility deployment, the entire application is containerized using Docker. So you can see the Docker file here. So we use lightweight Python, that is 3.11 Python base image. The dependencies are installed inside the container, ensuring the application runs identically across different environments. So when the container starts, it automatically launches the fast API application using UV icon. This allows entire system to be deployed using only two commands, Docker build and Docker run. So the testing. So the project includes test suite implemented with PY test and PY test coverage. Our project maintains over 70% test coverage, ensuring the reliability and preventing regression when the code evolves. So let me show uh, the ML Flow UI where you can see attention experiment. Here we have LRA baseline. And when you see the model metrics, you can see 88% accuracy we can see. And here also you can see the same structure which I have explained here. If you're going to scripts, you can see SRC, attrition, API, you can see models, data, everything. And you can see all the files here. Like Docker file, everything it is there. Okay. So going back. So to summarize, I would like to say the project demonstrate a complete end-to-end MLOps pipeline. We implemented a reproducible training workflow using split lane, experiment tracking with MLflow, and API-based inference using fast API, containerizing deployment using Docker, and automated code quality and testing practices. So all the project details and documentation which I have included in the README file, which I have, which is here as well, and we can see here as well. So I have added everything here, and thank you for listening me, Professor. Thank you so much.